Welcome. In this lesson, we're going to learn to write the equation of a parabola in vertex form given the graph and the focal point. What's nice is we really don't even need the whole graph. All we need is the vertex and either the focal point or the directrix to write the equation in vertex form. First thing we need to remember is that this h value inside the parentheses next to the x is going to be our x value of our vertex, and this k is our y value of the vertex. So for this particular parabola, our h value is 0 and our k value is 0. Then all we need to do is find the value of a. In the last lesson we learned that the distance between the vertex and its focal point, that focal length, which I designate with an f, is equal to 1 divided by 4 times the absolute value of a, whatever a is. I can rearrange this formula by solving for a, bringing the a up and the f down. In other words, I can know that the absolute value of a is equal to 1 divided by 4 times the focal length. So what's the focal length here? The focal length here is 1. So a, the value of this a that we're going to put in the equation is going to be equal to 1 over 4 times the focal length of 1, which obviously just means a is 1/4. This allows us now to type in the whole equation in vertex form. It's opened up, so we know our a value is positive, so it'll be a positive 1/4. 1/4. Then we would do parentheses x minus our h value, but remember h is the x position of our vertex, which is 0, so we don't really need to do the parentheses. We just do x squared. And then our k plus k is also 0, so we would just put plus 0, but we don't need to do that. So the equation in vertex form of this parabola is y equals 1/4 x squared. Excellent. Now let's do one that's opened left or right. Now, for a parabola that's open left or right, remember the x isn't the item that or the variable that's squared, it's the y. And then the vertical position is inside the parentheses next to the y, and the horizontal position of the vertex is on the outside. So here, if you notice, we have a vertex right here. So our vertex, and I might write this down, is at 0, 4 is where my vertex is. Now, it doesn't give me the focal point, it gives me the directrix. But remember, the distance from the vertex to the directrix is the same as the focal length. So I know my f value. I need to find a. I know k and h, right? Because remember, our vertex is our h is the x value, k is the y value. So I know my vertex. I just need to find my a value. And I'm going to take that focal length, which is 4 units. 4 units is my focal length. So my absolute value of a will equal 1 divided by 4 times the focal length, which is 4, or 1/16. So I know that my a value, when I type in my equation, this a value is going to be 1/16. I also know it's going to be a negative 1/16 because it's opened to the left. It's open left. So this formula, remember, doesn't tell you whether a is positive or negative. It gives you the absolute value of the a. And so you need to look at it and decide whether it's positive or negative on whether it's open left or right, or up and down if it's opened up and down. So this one I have all the information I need. I know this is an open left, so it's going to be an x equals. I know that my a value is a negative 1/16 because it's open to the left, and I found my a value by taking 1 and dividing by 4 times the focal length, where the focal length was 4. Now I'm going to do my parentheses. I'm going to do y minus the the k value, which what's the k value? It's 4. So again, it's a 4. So I'm actually going to put a 4 there, and then I square it. Then I'm going to add my h value, because the h is the horizontal position, but my h value is 0, so I plus 0. Whoops, 0, but you really don't need to put plus 0, so I just x equals negative 1/16 y minus 4 in parentheses squared. Hopefully this is starting to make sense. If you have questions, please bring them to class and I will go over this again.